everyone, it's Alyssa and welcome to You Can Learn Math. Today's topic is adding and subtracting rational expressions. If you're questioning what a rational expression is, there's a video I did previously talking about simplifying rational expressions. That's probably where you should start. In short, it is a fraction that has variables in it. Like say 3x over x squared plus 9. Any fraction that has variables in it, that's the shorthand definition. It's not the official definition. It's not how it's going to be phrased in your math books, but that's what it means. Now, if we're adding and subtracting rational expressions, because they are essentially fractions, they behave like fractions when we need to add or subtract them. Do you remember back when, like in elementary school probably, when you were adding and subtracting fractions? I know I'm probably bringing up trauma, but try to work through the pain. Let's say it was something like 4/7 minus 1/7. And your teacher probably showed you like, oh, if I have, excuse me. Sorry, I'm a little croaky today. I don't know what it is. I think my voice is a little overused at this point. Okay, so let's say if we have, oh, this is really not, that's the worst division. And I didn't even do it right. That's eighths. Oh, that's pitiful. Pitiful. Well, that's not too horrifically bad. That's so bad. We're going to pretend those are even. Try hard. Okay, so if it were sevenths, and the teacher probably said, okay, so imagine I have 4/7 and I take away 1/7. How many are left? 3/7. Oh, that's bad. We're going to move past this very quickly. 3/7. The main takeaway being the denominators had to be the same. And if they weren't the same, you'd have to multiply by something in order to make them match. Like if you had 3/4 minus 1/2, you have to make the denominators match. So for here, the 1/2, you would multiply by 2/2, which is the same as 1. 2 divided by 2 is 1. So you're not changing anything. 1 times 2 is 2. 2 times 2 is 4. 3/4 minus, wow, that's a really wimpy, there we go. 3/4 minus 2/4 is 1/4. The denominator has to match. That principle is what we're carrying with us today when we're doing these rational expressions. So you could, this is unlikely, you could get something as simple as, say, 5x over x minus 3 plus 2x over x minus 3. Again, unlikely they're going to be this nice to you, but maybe you have a nice math book. In this case, our denominators are already the same. So just like when we were saying 4/7 minus, what did I say, 1/7? 1/7, the denominators are the same, so you don't have to change anything. All you have to do is add the two numerators, the two numbers on top. In this case, 5x plus 2x would be 7x over x minus 3. You don't add these together because those are not quantities, just like with our circles when I was dividing them up horrifically, which I don't know why I'm doing it again. Why am I reminding you of my failure here? It's how many portions. And x minus 3 is a number. I know it looks weird because it has a variable in it, but it is just a number. Now, same thing goes if it was subtracting. Same idea. I'm going to throw one little extra wrinkle in here. Let's say if I had 7x plus 2 over x minus 3 minus 3x plus 4 over x minus 3. Now, this is still simple, but there's an important little principle here I want to point out. When you are subtracting these, please be careful and remember that you're subtracting the whole thing on top. You are not just subtracting the 3x. This is this thing on here this this set of numerators on top, if I wanted to rewrite this, it is not the same as 7x plus 2 minus 3x plus 4. It's the same as 7x plus 2 minus 3x plus 4. That is really a crucial difference, because that minus is not just minus 3x, it's minus 3x and minus a positive 4. So be really careful with those. So in this case, this would be, what I like to do is I like to do plus and then change the signs of both things inside. So that way I know it's taken care of. I combine like terms. 7x plus negative 3x is 4x, and 2 minus 4 is negative 2. If you need a refresher on combining like terms, video in the description below. So those are our big principles here. We have to have this common denominator. Denominator has to be the same, and be careful about those minuses. The first thing they're going to throw at you is usually something like this. Let's say 5x over x minus 3 plus, let's say, 2x plus 1 over x minus 8. For something like this, they want you to have that same common denominator. It has to have a common denominator. So think about, this is very similar to, let's say, if I had 5/7 over 2 plus 2/3. And these are totally different denominators, and there's nothing really in common between them. They're just totally different. If you were trying to add these together, what are you going to end up doing? You're going to end up multiplying by the other one, by which I mean this. The 7 has to be multiplied by 3, so you do a 3 over 3. The 3 has to be multiplied by 7, so you do 7 over 7. You do both of those, and then you can add them because they have this same denominator of 3 times 7, or 21. That's what you're going to be doing in these. When they are so radically different that there's nothing in common, you're going to be multiplying them both by the other one. So on this side, you're going to be multiplying this whole thing by x minus 8 over x minus 8. On this side, you're going to be multiplying by x minus 3 over x minus 3. And you're just going to distribute. Don't worry about combining the denominator. Just leave it as it is, as x minus 3 times x minus 8. Just leave it be. But you are going to distribute the things on top before you add. So up here, I have 5x times x is 5x squared. 5x times negative 8 is minus 40x. All that over x minus 8 times x minus 3. Next one, we got some FOIL action going on. All right, 2x times x, 2x squared. 2x times negative 3, negative 6x. 1 times x plus 1x. 1 times negative 3, minus 3. And if I combine these like terms, negative 6x, let me erase, plus x is minus 5x. All over x minus 8 times x minus 3. Now it's just a matter of combining like terms because this one is a plus. There's no minus to mess everything up. Woohoo! So if I combine like terms, I got my 5x squared and my 2x squared make 7x squared. Then my minus 40x and my minus 5x make minus 45x. And then just the minus 3 left on its side. And this is it. When you get to this point, it's always a good idea to check and see if your resulting polynomial that you've got on top, your new numerator, if it can be factored. Because if it can, then you might be able to cancel some things out like on top and bottom. But in this case, that's not what's happening. But just be aware of that. Keep an eye out for that. Now, after you've gotten some practice with those and you feel all confident and everything's awesome, then they throw the final form at you. And it looks something like this. 2x plus 1 over x squared plus 2x minus 3 plus 3x all over x squared minus 9. The instant there's an x squared in that denominator, I want you to think factoring. Like, I need to factor this first, if at all possible. Do not, please, 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 do not jump to, oh, okay, since there's nothing in common, I need to multiply this one by x squared minus 9 over x squared minus 9. And over here, I need to multiply by x squared plus 2x minus 3. No, 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 no. We don't want to do that. That will just make a mess. We need to do factoring of the denominators first. If you need a refresher on factoring, links are in the description below. I've got, old school factoring, grouping, coefficients, you name it, we got it. One-stop shop for factoring videos. So I'm going to assume that y'all know what I mean when I'm saying I want to factor this. I want to see what multiplies to negative 3 but adds to positive 2. So that is going to be x plus 3 times x minus 1. Okay, on the second one, x squared minus 9. For the bottom, I go, ooh, well, that looks like a difference of squares, is it? That's a square, that's a square, that's a minus. Yes, sirree, Bob, that is a difference of squares. So on this side, the square root of 9 is 3, so it's going to be x minus 3 times x plus 3. Now, if you'll notice, we've got something in common here. We've got an x plus 3 and an x plus 3. So the only things that are not in common are the x minus 1 here and the x minus 3 here. So that's what we need to multiply on the other side, those missing pieces, because our new denominator is going to be the combo of them. It's going to be x plus 3 times x minus 3 times x minus 1. Hee-wee. But yes, that is our full combo. So we want to multiply each of these by the missing piece. For this one over here on the left, the missing piece is x minus 3. So that's what I'm going to multiply it by. For this one over on the right, the missing piece is x minus 1. So that's what I'm going to multiply it by. Right, so when I distribute over here on the left, it's a FOIL situation. So x times 2x is 2x squared, x times 1 is x, negative 3 times 2x is negative 6x, negative 3 times 1 is negative 3. All over, no, I'm not writing it again, I'm feeling lazy. On the right, I'll write it at the end. We've got another distribution. 3x times x is 3x squared. 3x times negative 1 is negative 3x, all over all that again. Now I combine like terms between these two. I like to cross things out as I go. Got 2x squared and 3x squared is 5x squared. X minus 6x minus 3x is minus 8x, and then minus 3. Okay. And that is all over x minus 3 times x plus 3 times x minus 1. And that's our final answer. It's always a good idea to check and see if this final top thing can be factored. It can't in this case. It looks kind of like it can, but it can't. So if it can't be factored, then you're done. And that's it. You're all set. Move on to the next problem. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.